Hi folks, so this is question 9. So there's a triangle here, so we know it's trigonometry. And the first question asks is to find the area, so the area of field 1 and field 2. So area of field 1 will be simple enough. You just need to know the formula. It's in your log table, so you just need to know how to use it. So it's a half AB sine C. So that you generally use that one when it's trigonometry, when it's to do a triangle. So A and B need to be either side of the angle C basically, so that works in this case. So 35 and 30 are either side of the angle 50, so 50 will be C and the A and B are the 35 and the 30, so you just need to fill those in. And then you can put all that in the calculator together and it should give you the answer. So this is field 1 now. And it's 402 meters squared. We can find then, there's a few different ways you could do. You could go use sine rule and find some different sides. Find some of the other angles and then go that way. Or you could, what I'm going to do is I'm going to find the area of all of it. So I'm going to find the area of field 1 and 2 together. So the total area. So of both fields. So a half AB sine C, because we have everything we need to find the area of all of it. So the entire length of the bottom there will be 30 plus 10, so that's going to be 40. And then the area, the length of this side of it is 35, that's already given to us. So I'm just going to do the same thing then, and the angle is going to be the same as well. It's just that the length of the bottom will be longer. So a half times 35 times 40 times sine of 50. And then that's equal to 536. Let's round it off. And that's meter squared as well. So then we're just going to get the area of field 2. We're just going to take total minus field 1. So total was 536 and field 1 is 402. So we're taking them away from each other and we get 134 meter squared. So 134 for area for field 2 and 402 for field 1. So that's all the part A. Part B, we need to find the length of the perimeter of field 1. Okay, it's just field 1. So we have two of the sides, so a problem obviously is that we just need to find the length of the BC. So this is a very straightforward cosine rule question. So the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. So this is in the log table. So the side A here has to be opposite the angle A. So that's the main thing to remember when you're filling them in. And the B and the C will be the sides that are just beside A, that form the angle A. So in this case the angle is 50 and it's 35 and 30. So all of that then will tell us what a squared is. So again, use the calculator, and we get 775.1460. That only tells us what a squared is, so you need to do square root of that then to get a. And it's 28 when it's rounded off, because we need to get our final answer to the nearest meter anyway, so we're eventually going to have to round up anyway. So 28 then is the length, is this length here. And then you have the three sides of field A, so 35 plus 30 plus 28. And that's 93 then, so 93 meters is the perimeter of field A. Right, so for part C then, so there's an airplane going straight across in the air basically, and then Oscar's on the ground looking up at it. So if you look at diagram 1 there, ultimately we have to show that the time it takes is 41 seconds. So they want us to show that our answer is 41 basically. So they want to show that t is 41. So t, we know time will be distance over speed. So we know the speed of the airplane. That's simple enough. That's told to us in the question. So sound travels at a speed of roughly 343 meters per second. So the distance is the problem really. So we need to know the distance from P1 to Oscar. So from P1 to Oscar is this line here. So it's that part of the right angle triangle, and that has to be a right angle triangle as well. So we can use, it's a right angle triangle, we know one of the sides and we know an angle, so we can use SOHCAHTOA. So it's going to be adjacent and hypotenuse. So cos of 45 equals adjacent, which is 10 over the hypotenuse, which is the thing that we want. So it's PQ or PO basically. I'll just call it X for now. And then if you multiply by X, you get X cos 45, and then divide by cos 45. So X is 10 over cos of 45. And that's going to be 10 root 2. So 10 root 2 is the length of that. So we know what the distance is then, and we know what the speed is. So 10 root 2 over, and I'm going to write the speed in kilometers per second, because we're dealing in kilometers, so it'll be 0.343, and then that is what we get in the end. So we do get 41 seconds then, once it's rounded off, when we divide those two. So the airplane's flying at a constant speed then of 255 meters per second by the time. So we're using diagram 2 here. So we have to work out the size of the angle marked theta. So so we know a few things anyway already. We know that this is 10 here, from O to P. We know this is 10 root 2. From P1 to basically to the y-axis, then that's going to be 10 as well. You can use the fact that this is 45 down here, to kind of to know that. But if you're if you want, you could use Pythagoras as well. So 10 root 2 squared take away 10 squared and square root. So it's just a right angle triangle. So you will get 10 there again. So from P1 to P2, so is 10. Right, we want to work out theta eventually. The key thing here will be, we know that it's 10, it's a right, if you look at the little right angle triangle there, so this one, so I didn't draw that very well, but that little right angle triangle in there, that's what we're going to use. So the key thing here is actually this little bit. We need to figure out what that is, because if we know what that little red bit is there on the right hand side of the y-axis, then we can use SOHCAHTOA to work out what theta is. So the big thing is to find out the length of that. So I'm going to work out the full length from P1 to P2, and then I'm going to take away the 10, and that'll give me the little bit that's left. So to work out the distance from P1 to P2, we're going to use distance is equal to speed multiplied by time. Now the speed is given to us really, it's 255 meters per second, so in kilometers that's 0.255. But we need to know the time. Now we've calculated that in the first part, so that's 41 seconds. So that would give us the distance then. And I'm getting 10.455. Now, like I said before, we're only interested in the little red bit that I drew in earlier in the diagram, so I'm going to take 10 away from that. And obviously then you're going to get 0.455. So 0.455 is this bit here. So if I was to draw out that little triangle then a little bit bigger than is there, up here is 0.455, and then this here is what we're looking for, theta, and we know that this is 10. So we can use opposite and adjacent there, so we can use tan. So tan of theta is equal to 0.455 all over 10, because 10 is the adjacent in that little red angle triangle. And then if you put that on your calculator, you should get 2.6 degrees. And then that's that part. Okay. So part D then. So you must show this thing here, so it looks a little bit awkward. So when the plane is here at point 3, it gets to point 4, so it ends up here before Oscar actually hears it, and Oscar is down here. So what has to be the case then is that the distance from there down there has to be the same as that. So those two have to end up being the same. So let's just think about the distance from P3 to Oscar first, so just that distance there. So that distance, we know that, remember from before, that this was 10, so from O up to the line, directly up vertically, is 10. So you can kind of use Pythagoras then to get the distance from P3 to O, and that's where that top bit of the first part of the equation comes from. So you know that 10 squared plus d squared would equal to PO squared. So that should make sense. That's just Pythagoras. But then to get what PO squared is, you do square root. So you do square root of all of that. So that's 10 squared, remember, is the same thing as 100. So that's where your 100 plus d squared comes from. So that's where your 100 plus d squared comes from. The 0.343 on the bottom then, that's just going to be the speed of sound, because the sound has to get from P3 down to O. So that's speed of sound. So the bottom part of the line is the speed of the sound, and the top part is the distance from P to O. So that's the first part of it explained, and then so that's equal to 2d over 0.255. So 2d, you can see, is pretty much 2 times d, so it's just that plus that. So you can see where that's coming from then. That's the distance from P3 to P4. So distance from P3 to P4. That's what that is. The bottom part then, that's just going to be the speed. The 255, that's just the speed of the plane, isn't it? Yeah. So the aeroplane is flying at a constant speed of 255. So that's just speed of the plane. And that's where each of the things come from. So we still kind of need to explain a little bit why, or what it means, so why it holds. So each equation is basically distance over speed. So that's a distance, that's the speed of it took. So so altogether that will be the time it takes. So that's the time to get from P to O, and then this is the time. That's the distance from P3 to P4, and this is the speed from P3 to P4. So that's all together. Then that's the time it takes to get from P3 to P4. So you just need to write that down. I don't really have space here. I'll just write it up here. So the time to get from P to O is the same as time to get from, or the time, yeah. So from P to O is kind of the speed, is the time that it took for the sound to travel, and then from P3 to P4, it's how long the plane took, so they have to be the same. So that's the sound, and then this is the distance from P3 to P4, then that's the plane. So they're the same basically. The time it took the sound to travel is the same as the time that it took the plane to travel from point to point. So that's what it means. Then we just need the last bit of it then is just solving the equation. So you can cross multiply there. So 0.255 root 100 plus d squared is equal to 2d times 0.343. So let's square both sides just to get rid of the square root. So 0.065 times 100 plus d squared is equal to 0.47 d squared. So 6.5 plus 0.65 d squared is equal to 0.47 d squared. So you have a d squared on both sides. They're decimals now, but you can bring one over and take away from the other. That should actually be 0.065 in there. So you can bring that one. You can bring 0.065 d squared across the equal sign and take it away over there. So you should get 0.4056 d squared is equal to 6.5. So we just need to bring it. We just need to divide 6.5 by 0.4056 and then do square root. So I'll just do all that in one go. And we get 4 then, and it's rounded off, 4.0. Yeah, it says to one decimal place, so you need to put in the 0.0. So that's it, that's what D is, and then that's all for that question.